Bigels are a new class of soft materials that can help us potentially revolutionize the fields of regenerative biomaterials in healthcare and battery technologies for electrochemical energy storage and conversion. In our lab, we have developed materials processing protocols that help us transform bigels into structures that look like this, with applications ranging from battery electrodes in the field of energy storage and conversion, all the way to healthcare and regenerative biomaterials. We have a patent issued on transforming bigels into battery electrodes, and we have patents pending on transforming them into biomaterials that help the longevity of implants and medical devices. In order to make sure that medical devices and implants are not rejected by your body, you have to coat them with a material that would help your body accept that implant. Because of the special shape that bigel-derived materials have, they do two important things in this context. First, they allow blood vessels to come in, and second, they help the material to be accepted by the body. In electrochemical energy storage and conversion technologies, there are a number of applications that require you to deliver a high power, but deliver it for a long duration. For that, you need materials that can deliver simultaneously high power and high energy densities. The special morphology of bigels allows us to do that by bridging the world of supercapacitors that deliver high power densities with batteries that typically deliver high energy densities. So that, for example, you can charge your battery very, very quickly and then use it for a very long time. Bigels allow us to get to that space. In order to expand what we have done in the laboratory to commercial products, one of the problems that we have to solve is how to scale up this process of creating a bigel and then transforming it into a functional material, such as a battery electrode or an implant coating. Gravity adds another force to an already complicated physics problem that makes understanding this material on Earth very, very difficult. The International Space Station provides access to a microgravity environment and allows us to recreate a simplified version of this problem so we can understand its physics better and move toward large-scale production. Because of their special shape, materials derived from bigels may also find applications as heat pipes in the area of hypersonics that could help future space exploration. Because of the symmetry and tunability of bigels, with what we will learn from our microgravity experiments, we will be able to create a library of new materials and tools that help us address pressing problems in human health and energy storage.